questions in English, please. So this is the 5th video on chapter 5. This is going to be about naming type 3 or molecular or covalent compound. All of these are synonymous. Molecular, covalent, or type 3 compounds. So the first step in naming a molecular compound is identifying it as one. So remember, nearly all molecular compounds form from 2 or more nonmetals. So if you have a formula with nonmetals only, it's a molecular compound, or also called covalent compound, or type 3 compound. So we will learn how to name binary only, so with only 2 elements, 2 different elements in the chemical formula. So we will learn to name binary molecular compound, and that's going to be the rule. So the names will have the form of first a prefix in front of the name of the first element, and then a prefix in front of the name of the second element with the ending "ide". So the first element is named just like it is in the periodic table, with a prefix in front to tell the number of element of that first element. And then the second element will have the ending in "ide", just like in ionic compound. But we need, in addition to that, a prefix in front to tell how many of that second element there is in the formula. So naming molecular covalent compounds. So the prefixes here, when writing the name of a molecular compound, or when writing the formula, the first element is the more metal-like one. So in ionic compound, it was always the positive ion. But here, there is no positive ions or negative ions. It's all nonmetals. So the way to know which one is going first in the formula is the one that will be more metallic. So the more metallic one will be first in the formula. The prefixes that we place in front are indicating the number of atoms present for that element. So it's Greek prefixes. So mono indicates 1 element, di for 2, tri for 3, tetra for 4, penta for 5, hexa for 6, hepta for 7, octa for 8, nona for 9, and deca for 10. So these are the main prefixes that we will use. There's rarely more than 10 atoms in a formula. So you need to remember them, or I will provide them if necessary when a quiz or exam comes. So if there is only 1 atom of the first element, the prefix mono should be given, but it's omitted. So for the first element, when there is only 1 of it, we omit the prefix mono. So for example, CO2, the name could be monocarbon. So C is carbon. And then there is 2 oxygen, so di. Oxygen is, the root is ox, and then the ending ide. So that would be monocarbon dioxide, but we don't use the mono in front of carbon, and we say it's carbon dioxide. So remember, for the first element, we don't use mono. The compound N2O, also called the laughing gas, is named according to the first element, nitrogen, with the prefix di. So dinitrogen, followed by the base name of the second element, which is oxygen, so ox, and ended with ide. And because there is only 1 oxygen, we put the prefix mono in front and the suffix ide. So that would be dinitrogen monoxide. But since mono ends in a vowel and then oxide begins with a vowel, one of the O is dropped. And so the 2 are combined as monoxide. We don't say monooxide. So then the name would be dinitrogen monoxide and not dinitrogen monooxide. So you drop one of the O if there is 2 O's. And when the prefix ends with a vowel, like A or O, And the base name starts with a vowel also, like an A or a O. Then the first vowel is sometimes dropped, as in monoxide. So tetraoxide becomes tetroxide. Pentaoxide, for example, would be pentoxide. So we remove the first vowel when there is two, like A or O's. However, when there is two I's, we don't drop them because they are important. They are part of the name of the, like iodine, it's triiodide. We don't remove an I in this case because it's needed. And IO, we don't remove a vowel either. So dioxide, we keep it dioxide. We don't say doxide. So for the I's, we keep them. But the A's and the O's, if it's in front of another A or O, we drop the first one. So let's look at examples of naming covalent compound or writing the formula. So SO2, that's sulfur dioxide, because there is one sulfur, but we don't say mono in front, so it's just sulfur. Then there is two oxygen, so we will write the prefix di, and then oxygen makes the oxide, so dioxide. H2S, we have two hydrogens here, so it's going to be dihydrogen, and then monosulfide. Mono because there's one sulfur, sulfur becomes sulfide. So dihydrogen monosulfide. And 2O3. There is two nitrogens, so we say dinitrogen, and three oxygens, so tri, and oxygen becomes oxide. So dinitrogen trioxide. CCl4. There is one carbon, so we don't say mono, we just say carbon. And then there is four chloride. So 4 is tetra. So tetra, chlorine becomes chloride. So carbon tetrachloride. Let's find the formula for iodine tribromide. So iodine, the symbol is capital I. There is only one because there is no prefix in front, so that means it's one. So I. And then there is 3 bromide. Bromide is Br from bromine, and there is 3 of them. So IBr3 would be the formula for iodine tribromide. Sulfur hexafluoride. There is only one sulfur, so one S. Hexa is for 6. There is 6 fluoride. Fluoride is F, so it's going to be SF6. So let's go through a concept check, and so please pause the video before you watch the answers. So try on your own. And first it's to find the formula for those names. Xenon hexafluoride. Xenon is a noble gas, atomic number 54 in group 8A. Its symbol is Xe. There is only one because there is no prefix in front, so Xe. Hexafluoride. Hexa is 6, and there's 6 fluoride. Fluoride is capital F, so it's going to be XeF6, xenon hexafluoride. Dichlorine heptoxide. Dichlorine heptoxide. So dichlorine, that's Cl, chlorine, and there is 2 of them, so Cl2. Hepta, and here it's heptoxide, but the A is removed, that's for 7. There is 7 oxide. Oxide is the oxygen, and so that's going to be Cl2O7. Let's now name those formulas. PCl5. P is for phosphorus. There is only one, so we don't say monophosphorus, we just say phosphorus. And then there is 5Cl. So 5 is penta, So penta, Cl is chlorine, and it becomes chloride. We change the ending to ide. So it's phosphorus pentachloride. SiBr4. Si is silicon. There is only one, so it's going to be just silicon. Br4, there is 4 bromide, so 4 is tetra. So silicon tetra bromide. Br is bromine and it becomes bromide. So silicon tetrabromide. So in summary, how do we name ionic and covalent compound? The first step is to recognize, do you have an ionic or a covalent compound? That's a very important first step to accomplish before you try to name them. So the question is it made of a metal and a non-metal, or one or more polyatomic ions? And if you have a metal, just one metal is enough to make it ionic. If you have only 2 or more non-metals, then this is a covalent compound or molecular compound. So once you have decided the type of your compound, then for covalent compound, we just saw how you name them by using prefixes. But the ending of the second non-metal will be in ide. The first non-metal is just taken out of the periodic table. And for ionic compound, there is a difference. You have to ask yourself, is it a type 1 metal or a type 2 metal? If it's a type 1 metal, which means it's a invariant charge metal, always making the same ion, then you don't need to specify the charge in Roman numerals. But if it's a variable charge metal, then you need to specify the charge in Roman numerals after the name of the metal. And so the metal will be named just as it is written in the periodic table. And then the non-metal will have the ending ide. Or if you have a polyatomic ion, it's going to be the name of the polyatomic ion as it is in your list. So this is a flow chart that shows you how to name ionic and covalent compound. So it's just saying the same thing here. So covalent compound are made of non-metals only. For them, we use prefixes in front of the element's name. The first element is just as it is in the periodic table. The second one ends in ide. For example, P2O5 is going to be diphosphorus pentoxide. And for ionic compound, you need to decide if and so ionic compound are made of metals and non-metals. You need to decide if the metal is a type 1 or type 2 metal. So type 1, remember how it's those metals from group 1A, 2A, and 3A. And then there is some exceptions among the transition metals, which are cadmium 2+, silver+, and zinc 2+. So these are the type 1. They don't need a Roman numeral in parentheses to say the charge. Only the type 2 metal needs that. Otherwise, it's just the name of the metal, like it is in the periodic table. And then the second element, the non-metal, you take the root of the name and change the ending to ide.